Hello everyone, we are Team Raccoon and our project is dating recommendation using Neo4j, which is Checkmate. My team members are Maulin Dalal, Prashant Lotha and myself Prashant Yadav. Here is the agenda for this presentation. We will go through the introduction, system design and implementation, the experiment and POCs we conducted, the decisions we took, the difficulties we faced and the conclusion. We'll also go through a project plan and how we distributed the task, and finally a short demo of GraphDB and our application. So there can't be anything without motivation. And our motivation for this project was real-time recommendation system which can be scaled easily and will have good response time, which is very difficult to achieve with relational database. Our objective is to solve the challenging problem of recommendation, that is discovery, where you discover the data based on context, select the matched data and then present it in the efficient manner based on location, passion or interest graph. We did extensive market study and observed that graph databases are widely used for real-time recommendations. LinkedIn uses a proprietary graph database. Twitter uses dating sites like Are You Interested? Snap Interactive uses database, and many other companies. Now we will go through the system design and architectures. Algorithm is the crux of any recommender system, and every recommender system should follow these design principles: score and score transform. Whenever you are recommending something, you should associate a score with it, and to show how relevant the result is. Higher the score, more is the relevance. Context is needed for recommended systems, like recommending based on what: location, purchase history, interest, etc. Config will tell you how many values to recommend, the scoring formula that you are deciding. Blacklist is what are the things that should never be recommended to the user. Post processing will have things like increasing or decreasing the score based on few parameters, and this is done in this phase. Pre-computing: if you have huge data set, then you can pre-compute the results and provide the recommendation systems. Here's a list of the tools and technology which we have used. We have used Ruby to initialize the project. We have used Java for REST API. IntelliJ is the IDE. Neo4j is our database. CQL is the query to Neo4j, and Bootstrap is the user interface. So this is the typical graph model which is formed inside it. So here's the basic representation of the model: the property graph, which shows how the users Robert and Jennifer are connected based on location and interest relationship. So this is typical data flow we are considering for our application. User 1 inputs his preference, user 2 inputs his preference, user 3 inputs her preference. The model property graph is created and the nodes are connected if they have any connection. Whenever user enters, the Java wrapper fetches the common attributes which are matched, calculates the compatibility score and sort them based on the compatibility score and presents the results in a tabular format. This is the typical screen which we will show to the users with his or her potential prospects for dating. So the next part would be carried by Prashant Luthra. Thank you.
So I'll explain experiments we carried out for our project. We collected datasets online. This dataset was unstructured and required a lot of pre-processing. We developed a program in Java which transformed the data into the format that could be loaded using Cipher query language in the graph model we designed. We also collected data from the survey, wherein we asked our friends to fill out the Google forms which had fields such as name, age, gender, city, and their preferences for dating. This data was partially processed but still required processing. Query generated 16,500 nodes and around 4 lakh relationships that was stored in database. We collected and operated on 311 MB of data. The diagram shows how the data is extracted, transformed and loaded in the graph database. Unstructured data from the internet requires full pre-processing before it can be loaded into the graph database. And structured data from survey is partially processed but still requires some processing. Java program processes the data and transforms into the format that can be fed to graph database using Cipher query language. The data is loaded into the graph database. To evaluate the results provided by our recommendation system, we carried out few sample run on small dataset and verified the results. We created sample dataset and wrote simple cipher query language to generate recommendations for the user and verified the recommendation by executing the same query on Neo4j browser, which gave us clear picture of how different users are connected. Here is an example of how two users are connected based on location. The cipher query language is executed on Neo4j browser. When the execution is completed successfully, Neo4j generates a graph showing users, location and their attributes. The orange colored circles are the two users, purple colored circles is the location they live in, and green colored circle are the common attributes that one user wants and the other user has. So we analyzed the results from the sample data and saw how the users are connected based on the attributes defined. We used the formula to calculate the compatibility between the two users, which is given by number of common attributes user wants divided by the reciprocal of the number of common attributes the user has. This is the general formula used in most of the dating sites. We evaluated the results the cipher query language gave on Neo4j browser with result generated by the application and came to the conclusion that our project was correct and consistent. The further part of the presentation will be explained by Molin.
Hi, my name is Bolin and I'll walk you through discussion and conclusions and project plan and task distribution for this project. First decision we made was moving from conventional user recommendation to user item recommendation based on ratings provided by the user. With the datasets which we got, we could have only generated the user recommendation, and that too the recommendation would be pre-computed and not the real one. So to go for real-time recommendation along with fast results, we chose graph-based Neo4j database to do the dirty work of complex data storage. As we could not find the consumable data for our graph, we extracted disconnected data from the internet, wrote Java code to transform this data to the consumable format, and then used Cipher query to load the dataset. Eventually, we were able to calculate the compatibility of the users and successfully recommended. So now for the conclusions, GraphDB proved as a good for online dating recommendation. So we successfully created data set and recommended match users, verified recommendation results from using Neo4j browser, and GraphDB also helped us solving recommendation problems. Now we will now I will walk you through project plan and task distribution. So exploring the recommendation libraries, design and selection of graph model, data extraction, transformation, loading, UI integration, and the final round of testing of our application was done by Prashant Luthra. Prashant Yadav was in charge of exploring different dating sites and technologies used by them. Also, he was in charge of data extraction, transformation, loading, also creating project scaffold, Java RESTful wrapper over Neo4j, and setting up Heroku and trying to deploy our application on Heroku was done by Prashant Yadav. Exploring the different algorithms, writing test cipher queries, and collecting and processing Google Form data was done by me, and we were combinedly involved in exploring and understanding Neo4j and cipher queries. Our first, even initially, we thought of using Spark and Mahout, which did not work, and so we switched to Graph database. So after this, we'll show you the demo of our application. Thank you.
Demo where we will show the recommendations for different users. So now you can see recommendations for Janik, who is located in Honolulu, and these are the links. So what I'll do is I'll find the recommendations for a user called as Molin. So these are the recommendations for Molin which are generated real time, and as Molin is located in San Francisco, he's getting all the recommendations based on San Francisco and is sorted based on the compatibility. So what are these? These are the things what Molin wanted and Tiffany has, and these are the things which Tiffany wanted and Molin has. So typically this will be the output of the recommendation engine. And now to verify the results, I'll just show you the background query which is ran. Now this is a typical SQL as cipher query language which is generated, and you can see how these two users, Maureen and Tiffany, are connected based on the locations. So that was it for a simple demo. Thank you.